The horizontal asymptote is what happens when x is very large or very small. So when we put x in the denominator and we let it blow up, as x gets larger, 3 over x gets very small. So 3 over x as x gets huge, or as x goes to negative infinity, 3 over x is going to go to 0. X over x, that's 1. And 2 divided by a very big number, that's 0. That's 0 divided by 1. That's a real number. We're allowed to divide by 1. So this is the number 0. 0 divided by 1 is 0. It's when you have 0 in the denominator that it isn't okay. So our horizontal asymptote is y equals 0. Let's see. That's exactly along the x-axis. So we've got x equals -2 and y equals 0. And now it's just plug in a couple of easy values. So we have f of x is equal to 3 over x plus 2 . If I had 1 in the denominator, that would be nice. So let's plug in -1, because -1 plus 2 is 1. We get 3 over 1, and that's 3. That's the point. -1, 3. And let's see, if we let x be +1, then we'll have 3 in the denominator. 1 plus 2 is 3. 3 over 3 is 1. So we get the point 1 comma 1. We know we have a matching function in the third quadrant. Most of this function is in the first. But what really matters for us right now is just what's happening in that close-in value on the first quadrant. And let's take a look at, see if I can do this. Y equals 3 over x plus 2. So that's a nice image of the function, and I want to make it closer into our area. So let's do -3 to 6 on the x-axis, and -1 to I don't know what, but I'm going to square it. There we go. So we can see exactly what's happening to our function at these various values. And the point that we're interested in at first is the point 1 comma f of 1. Well, we already said that 1 comma 1, I'm going to make this a little bit bigger. So I've got the point 1 comma 1, and I want to find the slope of the tangent line to the point 1, 1 along this curve. F of x is equal to 3 over x plus 2. So let's see, to find the instantaneous rate of change at a f of a, 1, find f of a, 2, find f of a plus h, 3, simplify f of a plus h minus f of a all divided by h. Well, let's see. Okay, so we're going to use those steps every time. In this case, f of x is 3 over x plus 2. Okay, first let's find f of 1. We're looking for the instantaneous rate of change at 1 comma f of 1. That's our first thing. Well, we found this already, but this is kind of fun to do again. 3 over 3 is indeed 1, so we've got f of 1. Now let's plug in 1 plus h. So here, 1 plus h. So we have in the numerator 3, and in the denominator 1 plus 2 is 3 plus h. Okay, we've got the two parts, and now we're going to put them into the instantaneous rate of change formula. So the instantaneous rate of change at the point 1, f of 1, is the limit as h goes to 0 of f of 1 plus h minus f of 1 over h is the limit as h goes to 0. F of 1 plus h, that is 3 over 3 plus h. And f of 1 is just 1. And now we're going to use the information that I put in the review, that if we have a complex fraction, it's also called a compound fraction, both words are correct. That means a fraction inside a fraction, and we're calling the smaller fractions the inner fractions, and we're calling the big fraction the outer fraction. So what I want to do is find all of the denominators of the inner fractions and find their least common denominator, and then multiply numerator and denominator by that. Well, this time we have only one inner fraction. So the least common denominator of our only denominator, 3 plus h, is 3 plus h. So we're going to multiply numerator and denominator by 3 plus h. And now I want to distribute that, and I would really like to see this in 2 steps in your work. So I have the limit as h goes to 0. We have 3 over 3 plus h times 3 plus h. And then here's minus 1 minus 1 times 3 plus h. I'm just multiplying 3 plus h by both terms in the numerator, and then also both terms, the only term in the denominator. So we have h times 3 plus h. Now, let's multiply, simplify, and we're just about done. So we have the limit as h goes to 0. I have 3 plus h in a denominator, and I have 3 plus h in a numerator. Well, naturally, those divide out. So in the first part here, I just have 3. And now I've got negative 1 times 3, that's negative 3. And negative 1 times h, that's negative h. All divided by, we do not want to distribute terms in any denominators, almost ever, because we want this factor of h to be available to be divided out. Well, check it out. 3 minus 3 in the numerator, that's wonderful. All we have left in the numerator now is this negative h, so I've got the limit as h goes to 0, negative h divided by h times 3 plus h. Now we can divide out those h's. In the numerator, we have negative 1 left. In the denominator, just 1. So we have the limit as h goes to 0 of negative 1 over 3 plus h. Now let's look at this. Is it possible to let h be 0 and not have an undefined fraction? Yeah, sure. We can let h be 0 now. And let's, in fact, let it be green. So we're going to equals negative 1 over 3 plus, let me get negative 1/3. Remember that that's the slope of the tangent line. So let's go back to the pretty graph. Do you see that the slope of the tangent line at the point 1, 1 would be, it is negative, it is going downhill, but it is very slightly negative only. And even in the graph I made, I can see that it is very shallowly negative. Well, let's find the equation of the tangent line of f at 1, 1. So we have the slope is negative 1/3, and xy, that's 1, 1. So we get y equals mx plus b. 1 is equal to negative 1/3. X is 1, y is 1, m is negative 1/3, and we're trying to find b. Negative 1/3 times 1 is negative 1/3, and I'm going to add 1/3 to both sides. So that I get 1 plus 1/3 is equal to b. Well, in order to add these numbers, I need to have a common denominator. So I'm going to write 1 as 3 over 3. Do you see that 3 divided by 3 is still 1? So we haven't changed anything. We've just changed how it looks. And now we get 3 plus 1 over the common denominator. So the y-intercept, is the y-intercept the number 4/3? I want to hear everybody say, no, miss. That's right. The y-intercept is the point 0, 4/3. Well, let's go back to the graph and see if we can see that. I'm just going to type in y equals -1/3 x plus 4/3. Isn't that pretty? So it works. Great. Now let's do the fun one. Let's find, so let's write down the steps. I have f of x equals 3 over x plus 2. I need to find f of a, and I need to find f of a plus h. So let's see, f of a is just going to be 3 over a plus 2. And f of a plus h, I'm putting a plus h in for x, and that's just 3 divided by a plus h plus 2. Well, that's groovy. The instantaneous rate of change at the point A, f of a, is f of a plus h minus f of a, oops, the limit as h goes to 0, all over h is equal to the limit as h goes to 0. We have 3 over a plus h plus 2 minus f of a is 3 over a plus 2. And now we have, again, a complex fraction with two inner fractions, two smaller fractions. And let's do this. The least common denominator, a plus h plus 2, and a plus 2 is just the product of those two. A plus h plus 2 times a plus 2. So we're going to multiply numerator and denominator of our fraction by the product of the two inner denominators. So we have the limit as h goes to 0 of 3 over a plus h plus 2 minus 3 over a plus 2, all divided by h. And we're going to multiply that in the numerator by a plus h plus 2 times a plus 2, and in the denominator by a plus h plus 2, a plus 2. And now we're going to distribute and simplify. Simplify just means combine like terms and factor out anything that's possible. Okay, so we have the limit as h goes to 0. Three over a plus h plus 2 times a plus h plus 2 times a plus 2. So both uh, terms, we're multiplying both factors by the first term, and then minus, and then we have 3 over a plus 2. We're multiplying the second term by both factors. So it's a plus h plus 2 times a plus 2. And we're going to do the same thing in the denominator. It's important that we do not distribute and simplify the denominator. So we distribute and simplify the numerator. Okay, we can do that. The limit as h goes to 0. Now, let's see if this shows up. 3 over a plus h plus 2. We've got an a plus h plus 2 in the numerator and an a plus h plus 2 in the denominator. So we are left with 3 times a plus h, a plus 2, pardon me, and then minus, we've got this, we got a plus h, a plus 2, and an a plus 2. So those divide out. We're left with this 3 times a plus h plus 2. And the denominator is the big mess, but it's okay. We don't care. I mean, we're happy. We're happy about it. A plus h plus 2 and a plus 2. Now we want to continue to distribute and simplify the numerator. So let's multiply out. See what we've got. We've got 3a plus 6, negative 3a, negative 3h, negative 6, and in the denominator, h times a plus h plus 2 times a plus 8, a plus 2. Yes, groovy. And we have a 3a minus 3a and a 6 minus 6. So we're left only with negative 3h in the numerator. Please, it's not good mathematics to simplify by adding and subtracting like terms and dividing up terms between numerator and denominator in the same step. So we have to do those in separate steps. Okay, so we've got the limit as h goes to 0 of negative 3h divided by h times a plus h plus 2 times a plus 2. And what happy thing can we do? Absolutely correct. We can divide out that common factor of h between numerator and denominator. So we get the limit as h goes to 0 of negative 3 divided by a plus h plus 2 times a plus 2. And finally, we can let h be 0. because h is no longer a factor of the denominator. So we have the limit. We're taking the limit. So we have -3 divided by a plus something plus 2 times a plus 2, and we're filling in a 0 for the h. I do want you to show this step where you're letting h be 0. And now we're going to have two matching factors, a plus 2 and a plus 2. So I'm just going to write this as -3 divided by a plus 2 quantity squared.